Hey everyone, welcome to Area Between Curves. That's what we're going to be talking about here. And what we've done so far up to this point is we've done something like this. Find the area underneath this curve. So we said, really, let's take the integral, and we're starting at 1 and going to 3. So we're going to say we are taking the integral. So what we have done previously on calculus, we found the integral, and we said the lower bound was 1 to 3, right, of our equation. I'll tell you this is just x squared. So 1 to 3 x squared dx. And if we evaluated that whole thing, we would get the area underneath the curve that's down here. All right? So now let's throw something else into it. And there was kind of a question on here before, and I said, you've never done this before, and now we're going to be talking about it, is what happens if I give you this? And I say, let's throw in an extra line. And say, I only want to find this area in red. But let's say that originally, let's get this. Okay. What I had was we had found the area underneath this whole thing, right? We found the whole area, and now we want to remove part of that area. Okay? When you think about remove, you're thinking, oh, I probably need to subtract that area. And that's exactly what we're going to be doing. All right, so we want to take this whole area, and we want to subtract. We want to subtract the area underneath, basically this trapezoid right here, right? Because this is a line. Okay, so let's go through and figure out where do they cross? 1 and 3. Okay, so what we're going to do is we're going to do the exact same thing. We're going to take the integral, goes from 1 to 3, and we're going to take this top equation, the x squared. So I'm just going to write that up here. We're going to take the top one, which was the x squared, and I want to get rid of the area underneath the bottom equation. So we're going to say minus, right? We're going to subtract the bottom. So I'm going to subtract the x, and we're going to put that in parentheses and say dx. All right, so what will happen is I'll find the area of this whole thing, oh, come on, I didn't want to do that. I don't want that there. I wanted this, the area of this whole thing, and then we're going to subtract the area of this little stuff, and what we'll be left with is the area that's shaded in red. All right, so let's go through and actually do that right now. Let's figure out what is this area going to be. All right, so if I have x squared, that means I have 1/3 x cubed minus, and this is going to be 1/2 x evaluated from 1 to 3, right? All we really have to do is plug that stuff in, and then we have it. So now let's plug in 3, and I get 1/3 of 27 minus 1/2 of 3. And then I'm going to subtract 1/3 of 1, which is that, and minus 1/2 of 1, which is also 1/2. I'm going to put these in brackets just so that way I don't do something wrong and make a silly sort of mistake. So I've got 1/3 times 27, which is going to be 9 times, ooh, and this should be 1/2 x squared right there. So that should be 3 squared, so that should be minus 9 halves. There we go. Thank you for catching my mistake. Minus 1/3 minus 1/2. Okay, so 1 divided by 3 minus 0.5 is going to be negative and we go to and you get negative 1/6. So this whole thing is going to be negative 1/6. Okay, so now I can add positive 1/6, and then I'll just take 9 minus 9 divided by 2 plus 1 divided by 6, and I should end up with 14/3. Let's just check to make sure we got this correct, and the answer is 4.6 repeating, which is exactly equal to 14/3. All right, so that would be our area between our two curves. So it's this one minus the stuff on the bottom, and so it would be this area that's shaded in red. All right, so that is really what we're doing. Remember, and the biggest key I would say to do is to do this. Don't do that. Do this. Area of the, we want to take the top one minus the bottom one. I say one, top equation minus the bottom equation. There you go. All right, so now let's do an example. Let's look at this one right here. So I've got two equations, and they're in fact hiding behind me, so let's show them. They're up here. Okay, so we've got 2 minus x squared and x. So there's a couple of things we have to do. First, we need to figure out what are our intervals, right? Where are we going, where are we starting, where are we stopping? And then also, what's my top equation, what's my bottom equation, and then find the area. Now what's kind of interesting is that down here, this should be a negative area, right? So if I'm looking at between -1 and 0, for example, I've got this positive area, so when I take the integral of the top equation, this 2 minus x squared, I'll get the area that's up here, right? So let's just draw that in. So that means I'll get this area that's in here, right? Which is positive. Okay, and then if I find the integral from -1 to 0 for this one, I'll get this area, which we know is negative, right? But if I'm taking top minus the bottom, I'm going to be subtracting this negative, and you know subtracting a negative is the same as adding a positive. All right, so that means we'll really taking this area, and we're going to be adding this area onto it. So it does work out. All right, so here's what I'm going to ask you to do right now. First, tell me, if we're going from here to here, in between these two curves, what is the integral constraints going to be? Where am I going from, and where am I going to? What's the bottom part of the integral? What's the top part of the integral? So we're going to write out integral goes from where to where? Yes, the integral goes from -2 to 1. Okay, good. Next question. Which equation is my top equation? Which one is going to be the top? It is 2 minus x squared. So I'm going to do 2 minus x squared. I'm going to put it in parentheses. Okay, and next question. Which is going to be my bottom equation then? Which is the bottom equation? The bottom equation is x. So I want to subtract x, and then we're going to write dx at the end. All right. Now let's go through this, and let's do this calculus-wise. All right. So we're going to take the integral, which means I want to take 2 minus x squared. So 2 is going to get me 2x. Minus x squared is going to be minus 1/3 x cubed. And minus x is going to give me minus 1/2 x squared. Minus 1/2 x squared. All right, and then we're going to evaluate that from -2 to 1. All right, so now what we have to do is fill out all of our answers and do all of our stuff, and we're going to do this all correctly. So I've got the -2 first. I'm going to do the top minus the bottom, right? So I'm going to do 1 minus -2. Okay, so I've got 2 minus 1/3 minus 1/2. Right, that's when I put in the 1, the top part. And I'm going to subtract the -2. So it's going to be -4. And then -2 cubed is -8, so that should be plus 8/3, right? And then -1/2 times -2 squared, 4, so that should be -2. Okay, so now let's see if we can kind of put this all together. All right, so 2, and we can just take this right here. And we have 2 minus 1 divided by 3 minus 0.5. And I'm going to get 1.167. And if we just go and change that to a decimal or a fraction, we're going to say that is 7/6. So 7/6 minus -4 and -2 is -6 plus 8/3. So I'm going to do negative. Let's clear that out. -6 plus, not times, let's do plus 8 divided by 3. And you get -3.3. So it would be -3 1/3, which is -9, -10/3. Okay? So now it's 7/6 minus -10/3, so it should be adding a positive. So we got that number. Negative answer gives me here, and I'm going to do add. And now here's something we can actually do. If I want to change this to a fraction, but I don't want to do 7 divided by 6, if I go back up and highlight the previous answer, and I just hit enter, it'll put it right down in the spot where I want it to be at. So if I hit enter, there we go, I get 4.5. So we can add those together, and I should get an answer of 4.5. All right, there you go. So that's really what we're trying to do. Okay, and now I know you've got a question for me. And here's your question. You say, but Mr. Barman, what happens if the top curve and the bottom curve switch? Then what do I do? Well, I'm glad you asked, students. So here's an example. Look at that. I've got blue as the top until here, and then red is the top until here. So what we're going to do is we are going to do the exact same thing, but now what we have to do is we actually have to break it up into two separate integrals. All right. So the first integral we're going to have, it's going to go from -1 to 0. And then what is my top equation? Well, you probably want to say, what are my equations? Well, I'll tell you. F of x is going to equal x cubed. It's not x cubed. It's not just x cubed. It's I think it's 1/3 x cubed. Let's see if I'm right. 1/3 x cubed. I was right. And the other one is 1/3 x. So it's 1/3 x cubed. And then we're going to say that g of x equals 1/3 x. Okay, there we go. So now all we have to do is fill this out. So it's going to be -1 to 0. It's going to be 1/3. Yeah, 1/3 x cubed minus 1/3 x dx. All right, so that's the area of that one. If I want to find the area of the stuff on to the right of the 0 for x is 0, I'm going to say that's going to be plus the integral from 0 to 1, and that's going to be 1/3 x minus 1/3 x cubed dx. All right, and then we would just evaluate just like you did before. All right, so that is how you find the area between curves.